Eugenia sits near her bed in her sunny, ordered bedroom. Unlike in many teen abodes, the bed is made, no crumpled laundry is on the floor, and no stray shoes have escaped the closet. The 18-year-old's collection of Russian nesting dolls and miniature animals is dust-free, placed carefully on uncluttered shelves or atop a dresser near a mirror. Large windows look out over her leafy suburban Massachusetts neighborhood. In her lap, on an orange towel, are her two large guinea pigs, Wally and Stanley, which she strokes gently as they purr. She's alternately enthusiastic and shy, bubbly and easily embarrassed. Her strawberry blonde hair is long, perfectly straight and shiny. Her brown eyes provide a striking contrast to her freckles and light hair. After she speaks with Maya, she will drive to the local animal shelter where she volunteers almost every day, usually helping with dogs or rodents. A Shih Tzu puppy, now 6 months old and adopted from a shelter, runs in and out of her bedroom, each time demanding attention and bringing in a different squeaky toy. I don't miss people, Eugenia says, looking up and smiling nervously, because she knows that others consider it odd. I guess I don't get attached to people pretty much. I feel a lot closer to animals. Eugenia wanted to understand how early neglect affected people. And when we told her we were writing this book, she wanted to share her story to help others learn more about the development of empathy. Her case is nowhere as extreme as Oksana's. The type of neglect that she suffered is unfortunately far more common. About 19,000 children are adopted by Americans from foreign countries each year, and nearly 90% of these children have spent time in an institutional environment that can be considered neglectful because it fails to meet the developmental needs of young children. Nearly 500,000 cases of neglect by parents are also confirmed in the United States each year. Oksana is a previous book written by this author, one of the authors, about a feral child who was found raised in kind of animal, like an animal. By about 8 months, babies have usually built strong memory templates of their bonds with the people who appear in their daily lives. Now, being approached by strangers starts to cause fear and crying. They have built in enough of a catalogue of who is familiar and safe for them to recognize when they don't know someone. 8 and 9-month-olds are notorious for not wanting to be held by anyone other than mom, or whoever their primary caregiver is. This intensely tight bond rarely extends to more than one person, and will only extend even partially to others if those folks have been with the baby pretty much every day. Typically, they cannot easily be soothed by anyone but their primary caregiver. Secondary caregivers like dad or grandma or a big sister might do for a while, but mama is who they really want. Fathers often feel rejected by the strong preference that babies show for their mothers at this age, and feel as though they failed when they can't soothe them. But this is just a normal stage in the development of attachment, which gradually grows to accommodate more people as the child's brain becomes ready for this complexity. Now, in Eugenia's case, she was put into an orphanage. And that's just the background to this little bit. I've just edited this slightly. To baby Eugenia, the situation was baffling. Having been fed and nurtured by her mother for the first few months, she suddenly found herself in a world where she was just one of dozens of needy babies. Mummy was gone, as was everything and everyone else she knew in the world, although people don't have conscious memories of infancy. Babies' early experiences deeply imprint themselves into the brain. In fact, there is growing evidence that during pregnancy and in the first few months of life, babies' brains are more vulnerable to environmental influences than at any other time in life. As they say in computer programming, however, this isn't a bug, it's a feature. By probing the world around them for signals about the availability of resources, babies' developing brains begin to express the biological settings best suited to that environment. For example, if a baby senses, due perhaps to being underfed, that food will be hard to come by, her brain may express the genetic settings that preserve every calorie possible. If she's actually born into a world of plenty, however, that child is at risk of becoming overweight. In Eugenia's case, however, the orphanage was short on emotional rather than material resources. So that's the world for which her brain prepared. To those unfamiliar with an infant's developmental needs, the orphanage looked wonderful. The rooms were bright and open, there were plenty of toys. Babies and toddlers were moved from one activity to another. They were not left alone in their cribs. Staff monitored their play. Trees and grass surrounded the building. There were safe places to play in. And everything was clean and sparkling. You could eat off the floor, Sue says. Now, Sue is the adoptive mother of Eugenia. Eugenia was expertly changed and fed by a rotating staff. On the surface, it didn't look especially troubling. But in fact, it was a loveless void. In the orphanage, Eugenia wasn't special to anyone anymore. As Sue put it, the children were simply herded from one activity to the next, not played with as individuals. Eugenia didn't receive intensive, particularized adult attention and affection. To the staff, she was a job. Even though many may have truly cared and enjoy working with children, she still was just one of about 100 babies. When she returned years later, although some of the women who'd worked there in her infancy were still working there, now I didn't copy this, but to keep it short, but they didn't remember her. So what's going on and why does empathy matter here? The first person to study this issue systematically was René Spitz, an Austrian physician and psychoanalyst. Although he had no way of understanding the mechanism, he suspected that children in institutions were suffering from the loss of important relationships, and that connection between parent and child was critical to health. He didn't think that infants could survive, particularly psychologically, without that special attachment. He tried to understand that from the child's perspective. Soon he and another key theorist, John Bowlby, would begin to help the world recognize the importance of parent-child bonding and the attachment we now know to be so critical for so many aspects of health. In 1945, Spitz compared babies raised in the then typical sterile American orphanage with those raised in a cold institutional prison nursery. In the orphanage, there was one nurse for every 8 babies. There were sheets between the cribs in an attempt to minimize contagious disease. All day, the orphans lay alone, receiving little attention or affection. In contrast, the prisoners' babies spent most of their days with their incarcerated mothers. If the institutional setting itself and its inevitable germs was causing the child's bad health, the two situations should have been identical outcomes for babies. Alternatively, if what infants really needed most was individualized parental attention, the children in prison would do better. Spitz couldn't randomize babies from one setting to the other, but he figured that there were unlikely to be important distinctions between the groups other than maternal care. And indeed he found massive differences. There were glaringly obvious even without studying anything more subtle than the death rate. 37% of children in the orphanage were dead before they reached the age of 2, whereas none of the infants raised in prison with their mothers died. Lack of individualized care wasn't just unhealthy, he discovered, it was frequently fatal, killing more than 1 in 3 infants subjected to it. Though such a staggering infant mortality rate is common in situations without modern sanitization or medical care, it was not at all normal in industrialized countries even 6 decades ago. The prison children did better in every way that Spitz could measure. They contracted fewer infections, were healthier in general, and grew at the appropriate rate. They seemed intellectually and emotionally normal. In contrast, the orphanage children were often sick, didn't gain weight on schedule, and showed other signs of profound emotional disturbance, cognitive delays, and disabilities. The empathic connection the prisoners' babies made with their mothers literally saved their lives. Lack of love was what was killing orphanage children, not on sterile group living. Nonetheless, over half a century later, Eugenia and thousands of other babies were, and still sadly many are, being kept in settings where they don't receive individualized care. When Eugenia was adopted, she was in the 10th percentile for weight and height. She was tiny because, as we now know, individualized and frequent physical affection is needed to just spur growth hormone production. This is true for all mammals. When runts in litters of puppies and kittens die, these deaths are typically caused by the same problem. Runts tend to be too weak to stimulate their mothers to give them enough grooming and attention. They can't get access to or suck hard enough on a nipple to get noticed or nurtured. Without being nuzzled and licked, growth hormone isn't released. Even if a runt does then manage to fight his way to the nipple and eat, the food isn't metabolized properly, and he fails to thrive. Without the physical experience of love, the body senses little chance of survival and shuts down. In humans, failure to thrive, basically a cessation in normal growth and development, is a frequent consequence of orphanage life and other severe forms of neglect. In terms of IQ alone, the results were striking. At 42 months, the lucky children in foster care had IQ points nearly 9 points higher than those who stayed behind at the orphanage. I just want to interject something here. This is a different study. This was foster care and orphanage care. And if you have read the chapter, as you were asked, they talk in there about how they adjusted the study not to include anybody who was sick, so that there wasn't a predisposition to survive, so that the kids who were healthier were more likely to be fostered. So take a look at that and make sure you understand it. So anyway, in terms of IQ alone, the results were striking. At 42 months, children in foster care had IQs nearly 9 points higher than those who stayed behind at the orphanage. The average IQ of an orphanage child was 77, where it was 86 for the foster care children. Those who had never been institutionalized had IQs of 103 on average. The difference between foster care and orphanage children might not seem massive, but when you consider that the standard cutoff point for mental retardation is 70, these points can really matter. And even the children in foster care hadn't been placed there at birth. On average, these infants had already spent their first 21 months of life in an orphanage. That's nearly 2 years, at a time when the brain is at its most vulnerable. Even for something as seemingly unrelated to emotional development as IQ, empathic care is necessary for optimum development. Now, this is a different direction. Again, I didn't copy all the introduction because you're meant to read this yourself. But I just focused on the important bits. This is where it was noticed voles were studied for their empathic relationships. Anyway, voles are small, mouse-like animals, sometimes called field mice. If you've heard of them, you might have heard them called love rats. Outside of the scientific and pop sci literature on affection, they are best known for destroying lawns and gardens by burrowing into roots and eating grass. If they aren't eating your lawn, they are quite cute. Big-eyed, fuzzy brown balls of fur with shorter tails than house mice. And if you want to understand love, empathy, and social behavior, voles can be your best friends. Because as we've learned from the voles, the chemistry of monogamy and that of mothering are quite similar. In fact, oddly enough, the brain systems that allow mothering may have evolved and expanded into the neural basis for monogamy. It was only after studying monogamy in voles that the brain basis of maternal bonds first began to be understood. Papers on topics including sex, parenting, monogamy, aggression, and empathy would ultimately result from Getz's esoteric study of the love life of an unassuming field mouse. This research offers key insights into why social contact is so important to human health, how early childhood wires social connections into our brains to cope with stress, and how in humans empathy becomes possible. It is in large part due to vole research that we've begun to understand the physiology of how Eugenia's early life may have affected her brain. Getz and his team of assistant musketeers put tiny radio collars on prairie voles. They discovered that vole couples did indeed live together and raise young together, the males doing everything short of nursing to nurture their little ones, as well as vigorously defending their nests. Getz and his colleagues would ultimately study voles for 25 years, putting down 2,320,300 traps and handling 236,700 of the little creatures. No word on how often they got bitten. When he was sure he was seeing monogamy, Getz turned to a colleague, C. Sue Carter, to study the behavior of these unusual rodents in the lab. Unlike many biologists of the time, Carter realized that there had to be a physiology that drove monogamy, that something chemically must be different in prairie voles compared to other rodents. In other words, this behavior had to be based on a particular part of the brain. It wasn't likely to rely on general learning. Carter was already studying reproductive hormones and behavior, so she knew that in 1971, researcher Peter Klopfer had discovered that oxytocin was involved in mothering. Oxytocin had previously been identified by British pharmacologist Henry Dale as the cause of uterine contractions during labour. In fact, even today, a synthetic version called pitocin is used to induce labour or speed its progression in hospitals around the world. Dale named the hormone for this ability. Oxytocin comes from the Greek for fast birth. But Klopfer went further. His research, he believed, suggested that oxytocin was what he called the hormone of mother love. This made sense to Carter. Nature was often parsimonious. Why shouldn't a hormone involved in birth and nursing also help bond mother and baby? But Carter thought it might go even further. She wondered if oxytocin could be involved in other social behavior, perhaps in the monogamous relationships of these voles, in addition to their parenting activities. At the time, however, most scientists didn't believe that oxytocin was active in the brain. Over the years, Carter and her colleagues began to unravel the chemistry of connection, and it would help explain not just monogamy, but motherhood, but trust and friendship and stress relief too, as we shall see. As it turns out, other species of voles are not monogamous. Meadow and montane voles mate promiscuously. Their males are cads, not dads. Unlike prairie voles, montane vole males don't stick around and help with the young. If you ever want to keep your voles straight, just remember that prairie voles are not promiscuous and montane and meadow voles are not monogamous. The fact that such similar species show such different behavior was a boon to science. If differences was found in their brains, they would most likely be the source of the behavior that the research was interested in. So what's going inside their mousy little heads? As Carter, now known as the mother of oxytocin research, suspected, oxytocin, I had to cut that, sorry, I'll come back to it. It wasn't ruining the flow. Further research revealed that female prairie voles had a high concentration of oxytocin receptors in brain regions involved in the experience of pleasure. This pattern of receptors was quite different in promiscuous female montane voles. Few were located in pleasure regions. It was amazing. These females looked like they were literally wired to desire and get pleasure from one specific mate. The oxytocin connection connected the experience of being with their particular partner, that guy and him only, to craving and pleasure. Female montane voles, however, lacked these connections and could want and get pleasure from any male. The way this wiring is laid down is fascinating as well. Carter and her colleagues discovered that if a virgin prairie vole female hangs out with a male and mates with him for long enough, her brain changes radically. Prairie voles typically go at it in repeated bouts for 24 hours when they first meet. One mating is not enough to trigger that change that leads to bonding, but giving oxytocin, even if the voles just chill and don't mate at all, will do it. As noted earlier, oxytocin itself doesn't seem to be responsible for the actual sensation of pleasure during sex. It just connects the pleasure regions, which relates desire-linked dopamine and satiation-linked endogenous opioids with a particular partner's scent. If you block oxytocin or block dopamine in voles, no bonding occurs. In fact, blocking oxytocin in rodents produces social amnesia. They can no longer even tell one another apart, let alone figure out which guy or gal is their sweetheart. But allow oxytocin to flow, and prairie voles soon find themselves hooked on a one and only. Interestingly, however, monogamy in voles is rather like monogamy in humans, far from perfect. About 25% of baby voles are not genetically related to the father who shares their nest. Clearly, the female here is stepping out. As with humans, however, don't date married people remains good advice. In the lab, only about 1/3 of females will pick up and move in with a new lover and abandon their husband. 2/3 stay, even though some have dallied. Even in rodents, even among our best animal model of monogamy, relationships aren't easy or simple. Monogamy is, however, ineluctably connected to motherhood. Oxytocin researcher Larry Young, professor of psychiatry at Emory University, suggests that monogamy may have evolved when maternal nurturing and bonding, initially directed at babies, somehow expanded to include bonding with sexual partners. It's strange to think that mothers could have fallen in love with their babies long before they were able to fall in love with their sex partners. However, although monogamy seems to have evolved at several different times, it never did so in species that don't nurture their young together. Paternal bonding could have followed the same pattern, though Freud postulated that our psychology is shaped by an unconscious desire to mate with our opposite sex parent. This theory rather turns that one on its head. If Young is right, in evolutionary history, maternal love for babies came first.